Okay, so in this one, we want to find the work done by the force field F of xy equals x times yi minus yj in moving a particle along a quarter of the unit circle from 1, 0 to 0, 1. So how would you parameterize this circle? What would the radius on the quarter circle be if it's going from 1, 0 to 0, 1? 1, right? So the actual equation would be what? X squared plus y squared equals 1, right? So if you draw the quarter circle from 1, 0 to 0, 1, right, you're going to have this sort of shape. What would our parametric equation be for x? X would be just 1 cosine t because the radius is 1, right? And what would y be? Sine t. And to get just to trace out just the quarter circle, what would t have to range from? Not 2 pi. Pi halves, yeah, there you go. Right? Now let's use the other notation, just because we've done a couple of integrals in differential form today. So let's use the other notation. I want you to be fluent with both languages. So if we want to find the integral f dot dr, this is kind of the generic notation. So C is our quarter circle here. Then what's the working formula here? What's dr equal to? F dot, remember it's r prime of t dt? So I want you to memorize that over the break. Memorize all the different forms. And then of course this is equal to the integral of p dx plus q dy plus, if there's a z, r dz, right? Once you write it in that form, you've parameterized it with respect to t, so you know your limits on t once you get it in that form. So this formula, you flat out have to memorize it, or memorize this form and know what dr is, same thing. And then it tells you what to do. So r of t is really just the component form of our parametric equations, right? So r of t can be thought of as, in ij form, cosine ti plus sine t j. If you think of that quarter circle as a vector valued function, right? And then what is this formula? Look on the inside of this formula. What does it tell us to find? R prime would be a good thing to find. So R prime of t would be negative sine ti plus cosine tj, right? And then the vector field itself is xyi minus yj. You've got to put the x and y in terms of your parameter. You could do it after you take the dot product, that's fine, or before, it doesn't matter. So let's do it before. So let's write f in terms of t. Now, you know what x is. You could either look here or up here. X is cosine of t, right? And y is sine of t. You could either look there or there. So let's think, okay, x times y would be what? So, well, sure, I'm going to write it in the order, but it doesn't matter. Multiplication commutes. And then that's times I, right? So that's x times y times I we want. Everybody agree with that? And then minus yj, what would that be? Minus sine t times j. And now ultimately what you have to do to get your integrand when it's in this form is take the dot product, right? So let's do that. So take the dot product of r prime and f. They're lined. I like writing it this way because they're lined up. The guys you got to multiply together, they're lined up, aren't they? Go ahead.
Was the dr after the r prime for t? Is that still like going after it?
Oh, no, I should have written dt. Sorry about that. Yeah, that's a dt there, of course. Now, because once you've written it as f dot r prime, it's with respect to t, and you know your limits of integration. Thank you for pointing that out. Okay. So then take the dot product, and what is then f dotted with r prime?
Negative cosine t sine squared ti.
So sure. So negative cosine t times sine squared t, but no I, right? So dot product, remember dot product is always a scalar. So, and then plus or minus as the case may be. What over here?
Cosine t sine.
Yeah, cosine t sine, or sine t cosine t. So that's our integrand. Would everybody buy that? Okay. So then we set up our integral. Integral f dot dr would be the integral from what to what? Yeah, remember t ranges from 0 to pi halves. I think it might look nice if we factor out a negative. So then we'd have cosine t sine squared t minus cosine t sine t. And then parentheses around that whole thing. dt. Everybody buy that? Yep. Yeah, sorry. Copied it wrong. Or I didn't. I forgot I factored out the negative. Thank you. Everybody believe that? Okay. So, how do we integrate that thing? U sub what? Would it be the same u in both terms? So if you let, what are you going to let u equal? Sine, and then du?
1 over cosine t dt.
Look at it term by term. If you look at this, so here's my idea. I mean, you could separate it into two separate integrals added together, but I don't think you need to. So if we let u equal sine of t, then du would be cosine t dt, right? Yeah. And same thing here, right? So here's how I'm thinking of it, leaving the negative on the outside. Factor out a cosine t dt, and then without making the substitution, you actually have u squared in the form of sine squared t plus u in the form of sine of t, right? Does that make sense? And then, so this is your perfect du out here, and you should just be able to integrate sine squared as if it's u squared, and sine as if it's u. So let's do that. What do we get? So integral of u squared would be u cubed over 3. So the big bracket, sine cubed t over 3. Would you buy that? Then integral of sine to the 1 power, u to the 1 power. Sine squared over 2. Evaluated from 0 to pi halves. If you're not comfortable with that, make the substitution. That's fine. Just remember, you have to change the limits of integration on your u in terms of, to put it in terms of what u goes from, not what t goes from, if you make that substitution. All right, so what happens if we plug in pi over 2? What do we get here? Yeah, sine of pi over 2 is 1, cubed is 1, so 1/3. Yeah? And then plus 1/2. Do we get anything if we plug in 0? Right? So what's 1/3 plus 1/2? So negative altogether? So 3/6 plus 2/6, 5/6. And then the opposite out in front. That make sense? So what does it mean when the work is negative? Well, it just means it's working against the vector field. That's really what it means. So the vector field's not helping to move the particle, it's hindering it, right? Well, we won't get into it. Just the way I would think of it is the movement of the particle is generally, I don't know what this vector field looks like. I could graph it, by the way, in Maxima. But I do know that generally the vectors will be going, I don't know what the angle will be, but generally the vectors will be going kind of against the motion here. If that's what it means if I get a negative answer for the line integral. And since this is we're using the line integral to represent work here, it means the work is negative. The vector field's working against the movement.